Trivia. Today we are going to see the continuation of Geography of Grade 6, Lesson number 1, Mapping the Earth. Let's see globes and atlases. Globe. Globes are very small but true models of our Earth. Globes are the most realistic world maps. Atlas. An atlas is a collection of maps of the world, the containments on selected countries. Besides maps, atlas may also include information and diagram dealing topics with the earth like space and geographical features in a population data. So globe is a realistic world map. It's a true model of the earth, whereas atlas is a collection of maps. Map is a page where the entire earth is written, right? So in an atlas, one page will contain about one city or one country or one specific country, city or a state that we want to know about. Now let's see about globes. Globes are very small but true models of our earth. The earth is really 30 to 40 million times bigger than the globe in your classroom. Globes, unlike flat maps, are shaped like the earth, like a ball or a spear. The advantages are the globes, because they are round, put all the world's geography in one proper place. Hence, they give the most accurate view of the whole earth. The advantages is the most realistic model of the earth, and it also gives you you don't need to take so many maps. In one piece of big sphere, you can see all the entire earth and cities, countries and states. The disadvantage is globes are bulky, big and awkward to carry around when you're traveling. For travelers, it's not a good thing. Only a part of the earth can be seen on the globe at a time. You can't when you turn the globe, you can only see a part. Like if I turn it to the north side, I can only see the north side. If I turn it to west, I can only see the west. Like that, you can only see one part at a time. It does not show the details of small parts. For example, it is not helpful if you want to go to someone's directions to a place near your home. It's not really helping because it doesn't show accurate cities. It only shows states and countries. It's only good for explanation and teaching in the classrooms, but not good for taking directions to go to your friend's house nearby. An atlas. An atlas is a map usually printed in color. The relief of the land is shown by layer coloring using a set of standard convention signs, symbols and colors. The atlas map shows a great variety of features. Even the style and size of the lettering used for names of places gives a lot of information. Bigger places are named using bigger letters and bold font print. Smaller towns have their names in smaller print. As in any book, the atlas has a page of content in the beginning which lists all the maps and other information included in it. At the end of the atlas is the index. The index lists all the places in alphabetic order. So there is not advantage and disadvantage mentioned, but I'll tell you to you. Atlas is like a book that you can carry wherever you want, and it's not awkward to carry a big ball with you and going around. It's easy. You can fold it. It's a book, right? You can hold it, carry it very compactly, keep it in your handbag or your bag, and go. And it is really helpful because it shows all information. If, for example, in one page there will be India. In India, I'm taking a certain part, Mumbai or something. It shows everything about Mumbai and all the cities, states, all of them inside the particular area that I'm looking for. In the starting of the page, in this book, there will be India world map, the world map, all the world, whatever the maps inside the book. In the starting of the page, I would know. If you want to know a specific place, you can go to the last, like the end page, and you'll find our index. Our index lists all the places. Like if you want to go to a place somewhere in Agra, you want to go to Taj Mahal, then you can go in alphabetical order. You can see T and search there, or A. You can search for the places in the index. Next, let's see map projections. A map projection is a way in which cartographers show the curved surface of the earth on a flat map. So map projection is nothing but the way how are they showing the entire round sphere earth on a flat surface. How are they showing it? You're gonna see. It's impossible to draw a round earth on a flat surface. Rebounding the spherical surface on a flat piece of paper is a major challenge for cartographers. Every map has a disorientation. A map can retain either the correct size of the countries or the correct shapes of very small areas, but not both at the same time. The larger areas covered by the map, the greater the disorientations. There are maps called equal area maps which show the correct projection of different areas in the globe, but shapes as so much as areas are incorrect, especially towards the margin. Cartographers try to eliminate this disorientation in a flat map by using different map projections. There are over 200 kinds of map projection. The three main map projections are conical projection, cylindrical projection and azimuthal projections. So these are the three main we are going to see about. The first one, conical projection. What is a conical projection? This map is drawn as if a cone of the paper has been placed over the globe. Disorientations are the least in conical maps, especially near the line at which the cone rests on the globe. So it is like as if you took the paper and made a cone and made it sit on the earth. So this is a type of map projections. A few cartographers use conical projection, which is like it's a paper which is surrounded fully and it's like a cone, the top of the earth. Next, cylindrical projections. This map is made as if the globe has been wrapped in a tube or cylinder of paper. Cylindrical maps show the whole world in a single map, but is efficient to make the polar countries look like Greenland far too large. So the cylindrical projection is nothing but it will be a flat map showing every country and everything, but it will also be like if you take a globe and if you take the earth and wrap it around it with a paper and draw on it, that is how a cylindrical projection can be. And azimuthal projection is the normal map. This is a map made of as if it is flat sheet of paper that touches the globe at one point of the center of the map. Azimuthal maps can show only half of the world at a time. So all of these are showing a part, like the entire conical and cylindrical show the entire earth, whereas azimuthal only show a part of the earth at a time. So this is the map projection. Now let's see the elements of maps. There are 5 basic parts of elements of the map, which from important sources of information. These are title, direction, scale, legend and grid system. Let's read about one and let's know more about them. First one, title. Introduction to the topic. Direction helps find the way. Scale helps measure in distance. Legend or key explains the symbols. Grid system is something what helps to locate the systems. You might be familiar with longitudes and latitudes. Longitudes are nothing but they go from North Pole to South Pole. Latitudes go from east to west. There are lines that go around the earth which makes us point out the place easily. Now let's see the title. Not all maps use all the map elements. Most of the maps, however, do not use most of or all parts of the parts at one time. All maps should have a title which tells the reader what the map is about. For example, the map below is a wall map of the world. So a title is nothing but it is a bit main, because if you are buying a map or if you are looking into a map, you need to know what map you are looking at. In an atlas, if you have an atlas, there will be a title. Without a title, how would you know if it is a India map or a world map or a national map? You won't know, right? So the title is very important. So for example, there is a world wall map, physical map, political map of India, like that. There are many types of maps. Now let's see the directions. Most maps show directions with an arrow at the point to the directions of the north, called north line. Another symbol of the map that shows directions is the compass. sometimes called as the compass rose. A compass is a device consisting of the magnetic needle that is free to swing around. The compass needle always points north and south when it is at rest. With a compass showing where the north and south are, it is easy to travel in the straight line of any direction. Mapping languages begin with 4 basic directions: north, south, east and west. Directions help you answer the questions which way and enables you to find places. The 4 directions north, south, east and west are known as cardinal points of the compass. With the help of these cardinal directions, one can find out other intermediate directions. For example, the direction between north and east is northeast. So why does a compass always rest in north and south? So it is another topic, but it will tell you to understand this topic. When a compass is on rest, not showing any direction, it will rest in north-south direction due to the magnetic fields of the earth. The magnetic fields of the earth are strong at the poles, that is the north pole and the south pole. So the magnetic needle is pulled towards the force to the north and the south pole. This is the reason why the compass rests in a north-south direction. And cardinal points are nothing but, if there is north and east, in between north and east is northeast, east and south, southeast, south and west, southwest, north and west, northwest, like that. They are just cardinal points, is nothing but the between them both what will come, like that. That's all. On a map, the north line points to the north. If the north line is not shown, north is usually at the top of the map. The direction towards the north pole from any other place of the earth. South is just the opposite. It is always towards the south pole. East is direction where the sun rises every morning. West is where the sun sets. So there are, like, I'll give you easy things, okay? North pole and south pole you can find easily in any compass because the magnetic fields of the earth will force them. How to find south and east? How, if you ask now, when the side when the sun is arising is east. For the east right side is north, east left side is south, and from the opposite of east, that is west right side is north and west left side is south. So these are the directions. Next, when referring to any direction on the map, do not refer to them as the top or the bottom or right or the left of the map. Refer them as the north, south, east and west. Whenever you're using a map or guiding someone, don't say go down, go right, go left, go right. No, there are specific names: north, south, east and west. Similarly, when standing on the earth, do not refer to the sky as the north and ground as the south. That is very wrong. When you're referring the sky as the north and the ground as the south, then you can't go upright, like you can't go up. Refer your front as the north and your back as the south, okay? Don't refer the sky and the ground as north and south. Then both the sides will actually, you'll get very confused. Sky is nothing. See, the front of you is north, back of you is south, the right of you is east, the west of you is the left of you is west. So refer to your own signals. Don't think they're telling let's go up to the sky. No, refer to yourself. I'm telling you simply front, north, south, east, west. That's all. Don't get confused. There is not an arrow on the map pointing to the true north is a straight line to the north pole, but a compass needle always points to the magnetic north. See, when a magnetic compass always points to a magnetic north, not the true north, because it is pulled by the magnetic forces deep inside the earth. I told you magnetic fields or the forces are the same. The magnetic forces of the earth show the compass to the magnetic north, not the real north. The magnetic north pole is the point of the earth's surface towards which the north pole of all magnets are attracted. At present, it is located about 500 kilometers away from the north pole. The position of the magnetic north pole varies constantly. It is moving about 10 km to 40 km per year. So that's all for today. We saw till directions. In the next video, we'll see the rest of it. Bye all. Thank you.